Kangaroo Creek is just behind this hill, looking at the actual dam which has been created here in the actual river, looking down to the point where water is being released back into the river. Behind me is a Kangaroo Creek Dam in the River Torrens. The dam wall is just over there, and that actually is the Kangaroo Creek, and above it, up to a height of 500 metres and above, are potential sites for pumped hydroelectric schemes. In the headwaters of the River Torrens, the average rainfall is 687 millimetres, over half a metre rainfall every year in this part of the Adelaide Hills. If we look at the elevation profile, we'll see, starting at the headlands, it's at a height of 457 metres above sea level and has a steady decline as it moves across the Adelaide Hills until it reaches this point, which is the Kangaroo Creek Dam, and then falls away down to Athelston, where the elevation is 76 metres above sea level, so that the River Torrens falls just short of 400 metres between Athelston and the headlands. The study has identified numbers of sites in the Adelaide Hills, and these blue patches are designated potential dry gully sites for the storage of water high up in the mountains, and one of them of particular interest to us is this one, which is above this dam called the Kangaroo Creek Dam, because this gully has a creek running through it called Kangaroo Creek. If we look at the elevation profile, we'll see the foot of the dam is at 460 metres in height, and by the time it reaches the surface of Kangaroo Creek Dam, it's at 232 metres, which is a head or height difference of 230 metres. Kangaroo Creek itself has a number of potential other sites which I'd like to identify. This one starts at 541 metres above sea level and reaches Kangaroo Creek Dam itself at 235 metres, which is a difference of 310 metres between the top of the mountain and the water below. Another one is this one, where again there's quite a big difference between the headlands, 487 down to 232, and this one, if I switch the other ones off, it starts at 523 metres, again down to 232 metres, and this other one. This hill between these gullies is called Thomas Hill, and there's that looking down from Mount Thomas into the valleys on the eastern side around to the western side, and there's actually a study centre at this point on Thomas Hill. The hill on the other side of the gully, this hill is called Mount Misery. If we look at number 5, its elevation profile, it goes from 511 metres, the headland, down again to 232. Another potential site for pumped hydro is actually on the other side of Mount Misery, in another gully, and we look at the elevation of this one. It goes from 541 to 232. So you can see that in this region, on the southern side of Kangaroo Creek Dam, there are a number of potential pumped hydro sites which have the distinct advantage that there is already a very large water storage location, and at the moment there's no human permanent habitation in this region. An ideal site, I would suggest, for pumped hydro storage. This is the AEMO website showing the fuel mix for South Australia for the last 3 months. And so we can look at the moment, this is the 17th to the 18th of November, today is the 19th of November. We can see that battery storage was actually providing 13 megawatts, so 13 megawatt hours of energy between the 16th and 17th, and natural gas was providing 65%. If we go back, we can see there's a point here where gas has gone down to 23%, and wind has gone up to 74%, and solar is at 2%, and batteries at 88 megawatt hours. So it's fascinating as we go back through time. We can see how there are occasions when solar and wind is providing more than half of the energy that South Australians require. So at this point, on the 19th of September to the 20th of September, 66% of the energy was coming from wind, and 70% coming from wind, and 7% from solar and battery storage, given that we have basically, I think, 3 batteries now, very small batteries compared to the amount of energy we want to store, is providing 110 megawatt hours of energy. Pumped hydro would be an ideal way in which energy of the sun and the wind can be stored so that it can be used later. Just as electrical energy can be stored in a battery, it can also be stored by using gravity as a way of storing energy. This now is looking in real time, today being the 19th of November, in the middle of the COVID shutdown, interestingly, we can see that even though the sun's shining, and in Adelaide at the moment there's a gentle breeze, 3% of the energy in South Australia is actually coming from battery storage. None from the diesel backup devices which have been installed as in Adelaide. Natural gas is providing 39%, solar at 11%, and wind at 47%. In other words, 58% of our energy is coming from solar and wind, plus the other 3%. 61% of our energy is coming from battery storage, solar and wind at this moment in the afternoon of the 19th of November in real time. This is the information provided by the Australian National University study into pumped hydro schemes in South Australia with a potential 185 sites. The reservoir on the banks of the River Torrens by Kangaroo Creek Dam and Kangaroo Creek itself, reservoir 3784, has a potential to store 2 gigawatt hours. A gigawatt is 1,000 megawatts hours, so that's 2,000 megawatt hours of energy. If we look at the energy use in South Australia last night on the 18th of November between 1 o'clock and 2 o'clock in the morning, no energy from the batteries was used, no diesel. Natural gas, 741 megawatt hours of natural gas energy was used, 53%, and the wind was blowing. Obviously the sun wasn't shining, and 47% of our energy was coming from the wind. At 2,000 megawatt hours, we would not be switching off the wind supply, but we would stop using natural gas, and it's computed then that 2,000 megawatt hours would take the place of natural gas generation of electricity for nearly 3 hours. So for a large fraction of the night, the gas turbines would not be necessary to generate electricity. So 2 or 3 of these pumped hydro schemes, small hydro schemes, could completely take over the storage of the sun in the day and the wind in the day to provide energy at night instead of using carbon-based materials like natural gas and diesel. Dam with the associated Kangaroo Creek has the potential for at least one, if not more, places to store water. And over here we can see that the University of ANU has identified 5 other sites which are potential. Out of 185 sites that they've identified between the Fleurieu Peninsula down here near Deep Creek, through the Adelaide Hills, here at Port Augusta, Port Pirie and the Northern Flinders Ranges. Australia, and South Australia in particular, has abundant wind and solar energy, and the people of South Australia have embraced the adoption of solar panels by the very large number of houses now that are installing them on the systems. And this energy of the day needs to find a market to store the energy at night. Pumped hydro has the advantage of a very long life period, 100 years or more, whereas electronic methods using batteries might have a life period of 1,000, 2,000 cycles. A pumped hydro system will go through 700 cycles a year, and in a lifetime of 100 years, 700,000 cycles might be the potential for each of the pumped hydro systems.